Okay. But we didn't know the answers to a lot of things. Um, I can't use it as an excuse because I just didn't want God in my life when I was an evolutionist. I didn't want any of that to be true, but we didn't have any of this genetic information we have now. We didn't have the Human Genome Project. We didn't know that, if you look at Lucy's bones and whatnot and extract DNA, that it's just basically an extinct chimp. We didn't know that. They told us that she was a halfway, human thing. And some of the most fascinating things we learned are the Neander Valley or Neanderthal man, we call them, that lived in the caves during the Ice Age in Europe. Well, we see the DNA sequence of their material. They're just humans. In fact, some of the traits we can pick up in that DNA sequencing are in the human population all over the world. And we were looking last week or a few weeks ago when I was here at Nikolai, I forget his last name, Kosov. He is in Russian parliament. He was their heavyweight champion. He's mostly Neanderthal. I mean, he looks like the insurance guy. Yeah, only now he wears a suit to work. I got a picture of him with his family. Maybe we'll bring that up when we're done or something. Just as it's hilarious, but these people were just very intelligent, very strong, and very capable, and they survived in caves. So if a group of people separates from the general population and breeds within that population over and over again, they start looking alike, kind of like an island of poodles, that's what they look like. It's just that way with any people group in the world. And so that's all these guys were. But eventually, they just dispersed into the general population when the ice pack melted, and that's why their genetics or markers are in, all peoples across, the world now. So they're just people. They just looked a certain way because they were very isolated. Start off with a couple things, how awesome you're made. Think while you think with your brain. Think about your brain that has about 300 years of HD video storage within it. You guys have a cable or a DVR at home? You know how you kind of have to run out of room, you got to delete stuff, or if you had a cassette tape or whatever you're familiar with, you're going to run out of memory. Well, 300 years of high definition video is kind of the capability of your brain. Less than 4 pounds, pretty amazing. But what's really amazing is DNA and stuff like that. And we'll talk about that, because these are things that are not explained away by material or chemicals. You don't get information or languages from a chemical process or any material thing. So you can't explain these things. I mean, it's definitely a God thing. They only come from intelligence. They don't come from natural processes. So we'll talk about you guys and what this picture behind this means here very soon. I think you'll just kind of think that's super cool too. So we were made in God's image and in his likeness. I think this is really cool because he uses the plural, which means he's talking Trinitarian at the beginning. And you can say mind, body, spirit, or whatever makes sense in your mind as far as the Trinity works. But I think it's fascinating that the first thing that he gave all of us was his image to bear. That's pretty deep. So you don't really have an excuse to go running wild out there because you're bearing his image. You're an image bearer for Christ. And that's pretty deep. Think about that for a minute, though. But notice, though, when we see down here, he made male and female, and we know genetically that that's what we are. We're XX and XY. All this debate about, for like 6,000 years, there was girls and boys. And then for the last 4 years, we kind of had like 73 different things you could have been. And now we're back to girls and boys again, which is kind of cool, I think. I was kind of glad for that because I think it's true genetically. But at the end of all these things, he gives us the earth, he gives us the animals Ward talked about. He gave them commands to fill the earth by their kinds. And then he gave them to us to take care of. And he said, this is good. Not just good, but very good. Perfect. It was great. And we blew it all up, of course. But don't forget this one fact. In Genesis 2, verse 7, then the Lord God formed man out of the dust of the ground. He made you out of what? Adama means dirt, mud. We're a mud pie. And he breathed that life into the nostrils, and we became living beings. As a chemistry guy and an atheist, it really bugged me that dead chemicals somehow just sprung to life. It just doesn't happen. And there's a law in biology, Spencer could tell you, called biogenesis, which means life comes from life. You can't get life from something dead. It just doesn't happen. It's a scientific law. So you're dirt. So therefore, if we were to analyze soil, guess what? Chemically, you're made up of almost exactly what you would get if you grabbed a handful of soil and added water and some proteins here. But look at your chemicals and the balance and the percentages. You guys take vitamins? Why do you take them? So it's helped you restore minerals in your body that are leaching out because of entropy, which is the second law of thermodynamics. Science tells us we are literally made out of dirt. And you know how if you're out of balance you don't have just quite enough magnesium or whatever, I mean, it can affect your brain, behaviors. It's crazy how fine-tuned we are. But it's just exactly as he said. Dirt looks just like this, and that's what you are. How crazy is that? Well, what's more amazing to me, and I think you may have seen this if you were here the last time we did these, but I always like to review DNA with you because it's unbelievable what goes on inside a molecule that controls all the information within each cell of your body and tells it what to do, all the instructions to build it, tear it down, copy it, correct it. It's all contained in this acid, which we'll call DNA, deoxynucleic acid. But these little machines that are inside, though, the cells, and inside this molecule that we're doing this work within this molecule, are the most amazing things that you could imagine. And there's no reducible complexity of their design. They are just there. And if they weren't there, no cell would have ever divided the first time. They all have to be there at the same time. Not just the information and the languages to interpret it, but they all have their little jobs to do. And if they all aren't there, you could never have replicated or copied one of the cells as it was dying to have your mitosis, your separation. All parallel systems. But we've gone from the macro down to the micro, so let's watch this.
DNA is a good place to start, the double helix molecule we always talk about. This is a scientifically accurate depiction of DNA created by Drew Barry at the Walter and Eliza Hall Institute of Medical Research. If you unwind the two strands, you can see that each has a sugar phosphate backbone connected to the sequence of nucleic acid base pairs, known by the letters A, T, G, and C. Now, the strands run in opposite directions, which is important when you go to copy DNA. Copying DNA is one of the first steps in cell division. Here, the two strands of DNA are being unwound and separated by the tiny blue molecular machine called helicase. Helicase literally spins as fast as a jet engine. The strand of DNA on the right has its complementary strand assembled continuously, but the other strand is more complicated because it runs in the opposite direction. So it must be looped out with its complementary strand assembled in reverse, section by section. At the end of this process, you have two identical DNA molecules, each one a few centimeters long, but just a couple nanometers wide. So to prevent the DNA from becoming a tangled mess, it is wrapped around proteins called histones, forming a nucleosome. These nucleosomes are bundled together into a fiber known as chromatin, which is further looped and coiled to form a chromosome, one of the largest molecular structures in your body. You can actually see chromosomes under a microscope in dividing cells. Only then do they take on their characteristic shape. Otherwise, the DNA is more strewn inside the nucleus. The process of dividing a cell takes around an hour in mammals, so this footage is from a time lapse. You can see how the chromosomes line up on the equator of the cell. Now, when everything is right, they are pulled apart into the two new daughter cells, each one containing an identical copy of DNA. Now, as simple as this looks, the process is incredibly complicated and requires even more fascinating molecular machines to accomplish it. So let's look at a single chromosome. One chromosome consists of two sausage-shaped chromatids containing the identical copies of DNA made earlier. Each chromatid is attached to microtubule fibers, which guide and help align them in the correct position. The microtubules are connected to the chromatid at the kinetochore, here colored red. The kinetochore consists of hundreds of different proteins working together to achieve multiple objectives. In fact, it's one of the most sophisticated molecular mechanisms inside your body. The kinetochore is central to the successful separation of the chromatids. It creates a dynamic connection between the chromosome and the microtubules. For a reason no one's yet been able to figure out, the microtubules are constantly being built at one end and deconstructed at the other. While the chromosome is still getting ready, the kinetochore sends out a chemical stop signal to the rest of the cell, shown here by the red molecules, basically saying this chromosome is not yet ready to divide. The kinetochore also mechanically senses tension. When the tension is just right and the position and attachment are correct, all the proteins get ready, shown here by turning green. At this point, the stop signal broadcasting system is not switched off. Instead, it is literally carried away from the kinetochore down the microtubules by a dynein motor. That's the walking guy. This is really what it looks like. It has long legs so it can avoid obstacles and step over the kinesins, molecular motors that walk in the opposite direction.
You have to have every one of those components for a cell to divide, or the first cell could never have divided. Do you understand where I'm going with this? Do you think that the little walking guys evolved one leg at a time? I mean, we didn't know this stuff, in fairness to all us former evolutionary people. We didn't know this. Do you think Darwin never, even in his arrogance, would never have proposed it had he known this is what's going on inside a cell? These are micro machines, nanomachines inside the cell. Well, what happens in your bodies is this. What you just saw happening of a cell dividing happens roughly 23 million times per second in your body. That little activity just happened. You have roughly 50 trillion, 60 trillion cells, maybe upwards of 100 if you count bacterial, but this is happening 23 million times a second in your body. And so what happens, though, maybe if there might have been a copying error, what do you think happens? Well, there's a couple of things that are kind of cool. There's enzymes that run up and down. They're actually called editors, and they run up and down the DNA, and they look for problems, and they go, oh, I'm missing something here. I know what a good one looks like because I'm trained to do that. It's kind of like T cells in your body, but it's trained to look for these things, and they go, oh, there's something missing, and they call out through a signal to another machine that brings a piece, goes to the histones in the chromatids, and pulls out a piece of missing material and brings it to him for that location, and they repair it.
Oh my goodness.
That's new stuff, man. How cool is that? That's what you got going on. Look, Spencer just can't stand it. He's got to get in on it. Let's go. That's right, brother. No, he's outside. That's right. Because there's two languages. That's right. And so there's an RNA messaging component which sits outside. Doesn't even involve in that. Their job is to grab a bunch of acids and line them up right and make proteins. Right, Spencer? And those proteins are what they're talking about these guys are using. And they're like, hey, we need to make some more proteins over here. And those guys go, okay, man, we got you. And they create these things, and they're carried back into the cell and delivered to these enzymes that are correcting the problems. And they speak two different languages. One is speaking the ribonucleic languages, the mRNA, messenger ribonucleic acid messaging, which uses different letters, one different letter. These guys use a different language, which is the DNA messaging protocols. But there are actually chaperones which pick up the information, carry it to the guys on the other side. That's their job. They're called chaperones. And there's actually interpreters, like, oh, I can interpret that for you. And they actually can connect the two languages together. First of all, what chemical process can create information? There isn't any. What material process or chemical process can create a language which interprets the data that's there? There isn't any. And each cell, we're talking about two languages, two different sets of code. And even in DNA, they run in opposite directions and they have to be unzipped and zipped back together again. And that's happening, these copying of your cells, 23 million times per second. It's happening there 23 million times your cells did this. Cells cannot always continue to divide though. About between 40 and 60 we think is the limit, depending on the type of cell it is. No, times of replication, mitosis, which is interesting because what happens is, as we get older and entropy kicks in, we're not creating the material quick enough to replicate, to make up the difference, and so our hands and our skin doesn't look like it did when we were 15 years old. See, I knew it was going to be like this. I'll never get through this by 8, but go ahead. That's right. That's right. Yeah, exactly. And the older you get, the less material you've got to make new cells out of. But you know why fasting is really it's a biblical thing, but it's a really cool thing? Fasting gives your body a chance to actually reuse all the dead stuff and recycle it because that's what they do. There are machines that go around and pick up all the dead proteins and things and recycle them basically. But it gets to the point where the material is falling apart enough where it just becomes waste. And the older we get, the more of that we cannot recycle. It's just falling apart. Because they're dying, because they can only live 40 to 60 times. That's right. They got to have new ones coming.
I have a question. It's kind of
Isn't this awesome though? Go ahead.
Sorry.
Well, that's why we're here, man. Go ahead.
Sorry.
Okay. I'll leave that up to.
Hey, women, on their cycles, God.
That's right.
Made it specific on their cycles.
Yes.
Can you tell me what happens in replacing? Because in that cycle moment.
You're trying to replace chemicals that are being utilized in your body and whatnot. It's designed to do that. I remember we could only have, it was a miracle we even had our son, but we did, we had one. And they went through all this process and telling us all the chemicals had to be just right and all that. Has anybody have any kids or anything gone through IVF or whatever? I mean, they have to, that's like where you have to chemically kind of replicate what goes on naturally. It's unbelievable what you guys are doing and what he's doing inside your bodies to prep your body for a baby and then, carry it and then, and it just so happens on the 8th day you go circumcise your baby in the Bible, right? At the peak antibodies, the peak time where the blood clotting is there for the babies. I mean, how would they have known that? It's ridiculous, right? But that's what's in the Bible. All right. It's all part of his design, though. It's all part of having babies because he wants us to propagate. So in 2023, the most detailed model of the human cell to date, actually it started with an animal cell, and then they did a human. They're very similar. The mammals and the humans are almost identical. So they used X-ray and a bunch of other really cool technologies to try and see what in the world, let me see where these nano machines that are in each cell, what does it look like? And this is the image that they came up with. And what we were just looking at was like perhaps the DNA component. We're talking about just a small component near the nucleus here. But we're looking at little DNA components maybe, and machines related to that. There are over 1 billion molecular machines in each cell. There are 1 billion of the little walking guys in each cell, and you're carrying around between 50 and 70 trillion cells in your body that are replicating at 23 million times per second. I'll just leave it like that. Is God awesome or what? Can I get an amen on that? But I'm a data guy, spent like 30 years in information systems, right? So I got, I'm always updating this, Mike, and this might be new to you too, so this is kind of cool. So how much data is in the world? You guys will probably dig this. There's a company called Statista, and you can go to their website. They have data on all kinds of cool stuff. It's crazy, the stuff they track. But they track how much data is in the world at any given time. They're estimating this year that we're going to hit, actually by the end of the year, and we did hit very near this number at the end of the year, 70 trillion terabyte. So does anybody have a terabyte phone? Where's my younger people? Do they have an Xbox? It's probably a terabyte. I mean, that's a lot of data, right? So that, basically, if you had a terabyte phone, which is like the newest high dollar iPhones and whatnot, you're talking about 15,900,000 tons of terabyte phones to carry the world's data on smartphones, to store and retrieve them. And that's based on them all being about 7.5 ounces apiece, 7.27. So understand the world's data is 70 trillion terabyte. That would be almost 16 million tons of terabyte phones. It's going to take 16 million tons of these to carry the data. So, if they were all what they are, 0.31 inches thick, like stacked like pancakes, they would go all the way to the moon. That's how much data is in the world if you put them on iPhones or smartphones. Well, Georgia Tech researched 15 billion terabytes of data they found they could store and retrieve, converting into the language of DNA. 1 ounce of DNA could carry 15 billion terabytes of data, each ounce of DNA. That means the entire world's data could be stored in 4 ounces of DNA material, like what's in your body. That's a quarter cup if you're a baker. More so, Nicholas Geis, who's the guy down there at Georgia Tech, says, you know what, we could take all the video, all the media, multimedia we have in the world, in the history of the world, all the movies, all the Snapchats, all the YouTubes, everything that exists, and it would fit in a sugar cube of DNA. Do you think that that's by chance? This system that's constructed to store and retrieve data, it's crazy. What about your heart? Well,
Did you know? The human heart
talk
is an
about that
amazing
for a
pump.
moment.
It starts beating and pumping blood 4 weeks after conception and never stops until death. To keep you alive, the heart circulates oxygen and nutrient-rich blood throughout your body. A healthy heart pumps 2,000 gallons of blood through 60,000 miles of veins every day, yet weighing just 11 ounces on average. The heart muscle is made up of thousands of small cells. By delivering an electrical signal through these cells, the heart's electrical system controls the timing of the heartbeat. The electrical signal controls the heartbeat through 2 types of cells, which are the conducting cells, which carry the electrical signal from the heart, and the muscle cells, which allow the heart's chambers to contract, which is activated by an electrical signal from the heart. The average adult heart beats 72 times each minute, 100,000 times each day, 35 million times each year, and 2.5 billion times throughout the course of a lifetime. The heart generates enough energy to drive a vehicle 20 miles every day. That's the equivalent of driving to the moon and back in a lifetime. The heart is responsible for pumping blood to almost all of the body's estimated 75 trillion cells. Only the corneas are deprived of blood. The heart pumps roughly 1.5 million barrels of blood in a lifetime, enough to fill 200 train tank cars. It is quite obvious that the human heart was designed by an engineer with superintelligence. When you look at its complexity and what it does to pump blood throughout the whole body for a lifetime, there is simply no way that this could have happened on its own. Yet, evolutionists like to tell their tale that the human heart developed from less complex organisms over a long period of time.
Wait a minute. What's the problem with that assumption that it would develop over time? You got to have a heart or you'd be dead in a couple of minutes. In fact, Franklin Powers, who is this guy at Washington State, said, I realized my evolutionary belief system was in turmoil and in absolute retreat when I came up with an estimation that I could only live a few minutes without a heart. It had to have come online ready to go. And because all the other systems in your body use it and leverage it. They can't do without the flow of the blood. What about blood clotting? The first cut Adam would have got, he'd be dead. You'd have bled to death. We wouldn't have had any other children or anything else, right? It's just incredible how wonderful you're made. And the heart is another one of these parallel systems you have to have for everything else. And it has to be online, like the ear in its 5 components, like your eyes, like your brain.
Did you know? The brain is an extremely complex organ. It controls thought, emotion, memory, motor skills, vision, touch, temperature, breathing, hunger, and every process that regulates the body. If you were to look at a piece of brain tissue, and it was the size of a grain of sand, you would see that it contains 1 billion synapses and 100,000 neurons. What's even more amazing, they're all in communication with each other. The storage capacity of the brain is virtually unlimited. There are around 86 billion neurons in the human brain, and each neuron forms connections with other neurons. This could equate up to 1 quadrillion, 1,000 trillion connections. These neurons can combine over time, which can increase storage capacity. No computer on Earth can do this. The information in your brain can travel up to 268 miles per hour. The stimulation of a neuron generates electrical impulses, and this travels from cell to cell. Your human brain is able to generate about 23 watts of power, which is enough wattage to power a light bulb. The brain is simply amazing. With all of the power and functions going on to enable our bodies to work, it really is the most unusual and amazing part of our bodies. From the number of neurons firing to the storage system used by the brain, it's truly incredible. On top of that, the human brain controls the even more complex systems of the entire human body. It is quite obvious that the human brain was designed by a super intelligent engineer. When you look at its complexity and what it does to be the command control of the whole body, there is simply no way that this could have happened on its own. The evolutionary story is that the human brain developed from less complex organisms over a long period of time without any intelligence or mind behind this. There is, of course, no observable evidence for this, as it's all conjecture. It's a fabricated tale.
Do you think it's a fabricated tale? By the way, how did the brain have what it needs from blood for its oxygen to operate without a heart? You can't have it that way. They had to come online at the same moment in time. You know, it's just incredible. Here we have Watson, who still kind of clings oddly to almost an evolutionary thought process, or he did, at least near the end of his life. But he said, you know what? This thing is the last frontier. There are hundreds of billions of cells interlinked through trillions of connections. It boggles your mind. I love this one. What about your eye? Which, by the way, the synapses, they're connected to paired nerve endings in your brain to your eye. If they're, you know, like if anybody had eye surgery, they can, you know, they've got to, and the retina and all that, they have to attach all these things just right so it works, right? I mean, it's crazy. So they had to come online at the same time and fit just perfectly together. And here you have a statement that says, you know, all of this complexity, focusing, its aperture, letting light in and out at different amounts of time, you know, to say that this could have formed somehow slowly through natural selection is absurd in the highest degree. Who said it? Darwin did in 1872. Even he knew that you couldn't get an eyeball out of evolution. By the way, what was the one part of your whole body that doesn't have capillaries, doesn't have blood flow? Yeah, the cornea in front of your eye. Why would that be? So you can see. That's crazy, isn't it? But it does not have blood flow. Incredible. What's the possibility that that we could have what we have, even one protein or one life form or anything mathematically?
Probability is a field of mathematics that assesses the likelihood of an event occurring. Given enough information, all of the possible outcomes or arrangements of a situation can be determined. Mathematicians can therefore predict with considerable accuracy the possibility of an event occurring. When probability is used correctly, it can accurately predict the likelihood of election results, life expectancy of a population, likelihood of one purchasing a certain item. Let me give a simple example of probability. If you had a single die, the likelihood of rolling a 1 is 1 out of 6, as there is one desired result out of a total of 6 results. If you had a 10-sided die, the likelihood of rolling a 1 is 1 out of 10. In order to show this, we can first express the chances in a different way. 1 out of 100 would be 1 over 10 raised to the power of 2, because there are 2 zeros. 1 out of 1,000,000, 1 over 10 to the power of 6. In mathematics, if the chances of something occurring are less than 1 over 10 to the power of 50, we generally say the chances of that event are nil. That is, it will not occur. This is because 10 to the power of 50 represents a number that is far greater than the estimated number of planets in the entire universe. The development of life from simple non-living matter represents the coming together of various molecules to form more organized and complex structures, which includes very intricate and essential molecular machines. Thus, the spontaneous development of life requires things moving from less order to more order. Evolutionary thought is predicated on the premise that matter can move to a higher state of order in an unguided or accidental way, not only once, but with literally millions of steps along the way. Mathematics holds an opposite view. To evaluate the likelihood of this possibility, mathematicians would first consider the second thermodynamic law, called the law of entropy, a law that demonstrates that all matter will tend toward a state of maximum disorder unless acted upon by an organizing force. As Dr. W.H. Thorpe puts it, the likelihood of life occurring by chance is fantastically improbable. The spontaneous formation of life violates the second thermodynamic law, which states that all closed physical systems tend toward a state of maximum disorder. According to Dr. Jean Morton, the probability for arranging amino acids for 10 enzymes would be 1 over 10 to the power of 113. It is estimated that the human body contains 25,000 enzymes. If each of these were only a small enzyme consisting of 100 amino acids with a probability of 1 over 10 to the power of 113, the probability of getting all 25,000 would be 1 over 10 to the power of 2,825,000. To put it another way, former astrophysicist and head of mathematics at Wales University, Dr. Wickramasinghe, and English astronomer Sir Fred Hoyle, who formulated the theory of stellar nucleosynthesis, described the likelihood of human evolution to be as mathematically plausible as, and I quote, a tornado blowing through a junkyard and leaving behind a complete and flyable Boeing 747. In the case of the 747, the organizing force which assembles it is a labor force of men and women. In the case of the cell, evolutionary scientists are turning over every rock in search of events or natural phenomena to explain evolution's triumph over probability and the known laws of nature. These men I have quoted are some of the most respected mathematicians on the planet. They are not religious nutcases. They have looked without prejudice at the notion that life evolved by chance from non-life and has progressed through natural selection into the complex forms we have today. And they have come to the same conclusion. To accept evolution, one must first accept that the impossible happened.
Well, good luck with that, if you are. Was that awesome? Does that encourage you? We want to thank you guys for having us out here. It's a little bit before 8 o'clock. You could ask a few questions if you want to, but yes. Well, you know, it's not a full-time job, but it feels like one. We have
Pollution, they just pop up.
We have a lot of contacts, that, especially the guys that do the John 1010 project, like Lad Allen. He was a movie producer and made secular movies and got saved. And he realized his grandkids up in Oregon were lost. And so many years ago, he started his Illustra Media. And so Lad Allen does a lot of this great stuff that I've been, and we've actually worked with him and talked with him. And the animal video that Ward used was one that we asked him for, and he said, well, here, check this out. He puts a new one out probably once a month, maybe once every other month. John 1010 Project. Go check it out. That's a good place to go.
And
I like GenesisApologetics.com too.
He does that and gives them to his grandchildren to try to convince them that there is a God.
Yeah, to encourage them in their faith.
John 10:10,
Project, that's right. But yeah, ICR and Answers in Genesis and all that stuff. We don't really consider ourselves quite like those groups because we kind of go really deep in a subject with people one-on-one and try and build your faith and encourage you to think critically, as Ward said. And we're not really we're not looking to just do kind of a high-level presentation on creation or something. We really want to go scripturally through things, and we want to go deep and inspire you to think about what God has done and use your head to, to think about just how awesome he is. And really, we love to catch college kids. I mean, we've done a lot of that kind of stuff, and we do a lot of stuff in schools around here. And that's where it's at to me,
Can you explain that sickness or illness is not an interruption in the DNA cycle?
Sickness or illness is not an interruption in DNA.
There's not a bad guy that attacks the DNA that causes...
There are bacteria that attack your cells. Yeah, they're bad guys. Yeah, and you've got T cells that they're like SEAL team scouts that come in and look at everything, and they kind of get an understanding of what's going on, and they identify the threat, and they teach everybody, look for these guys and take them out. One of the big problems we had with the method we used for our COVID vaccinations with trying to use messaging RNA is we kind of turned on the high alert for everything, and our systems couldn't find the real threat. And so the people would have these hyperactive responses to that because they didn't know, your cells didn't know the white blood cells and whatnot, didn't know what to attack, didn't know to send the resources because everybody was a bad guy. And that caused a lot of problems. That we shouldn't be messing around with mRNA. When we only understand 30% of the DNA and the mRNA, we shouldn't be trying to use something like that on people, in my opinion. But that's, I don't know if I upset somebody here or not, but that's just the truth of the matter. No, they cause more because we don't know what all that stuff does. We thought that was, as an evolutionist, we thought it was junk DNA, right? But we come to find out the timing sequences and things are in this. And none of it's junk. We just don't understand it. So you start monkeying around with things you don't understand, you're going to hurt some people, and we have. Yes, sir.
So, looking at the abortion issue.
This is great. I mean, we've just gone, whew, let's go.
Okay. Why hasn't this become more relevant to when human life actually begins?
And it begins right there. You can even see the spark of life at insemination when that happens. Yeah, I don't, why is evolution still taught in schools when it doesn't even pass the hypothesis stage? It's not a theory. It never made it that far. It's crazy. But that's what we, because there's agendas behind these things. Who's in charge of this world today still? Exactly, the prince of the air till his time is up. So why would he want people to know, truth?
Yeah, I think it's kind of a malaise that the evil one puts out there. And just like the Jewish people, God's kind of caused them not to understand that Jesus is the Messiah until he's ready for them. A few do, obviously, but the majority don't. But there's a time coming when they will, of course. But there's a malaise over the Jewish folks. And I think the evil one has spread this. That's a God malaise. This is a devil malaise.
I wonder how many times in the Bible it says that he hardened their hearts.
Well, Pharaoh got a good helping of that, didn't he? But and in Romans 1, he just kind of says, eventually I just got to let it go. Ephesians 6 is really kind of... We were talking earlier with at least a few people. Well, what about aliens? Well, okay, so from an evolutionary standpoint, if they're more complicated than humans, who made them? You just keep kicking the can. See, that doesn't work anyway. But they're not. It appears to me to be a deception of sorts, and that kind of goes back to the evil one, which would tell me that these are probably Ephesians 6 kind of dark power things that are being used to manipulate people and stuff. That would be my own personal. I don't believe in aliens. I believe they're aliens to our world because they've come from their realm. Like Jude says, they left their proper abode.
They do live among us.
Yeah. It's true, but don't get all weirded out over aliens. It's all just something to kind of distract you from Jesus, right? So,
I think if we had a good paraphrase of Job, we'd understand everything.
Yeah, Job was pretty
Tina and I
awesome.
just got through and we're both sitting there going,
We're like, what does he mean? It's confusing.
It's the only one that puts me to sleep is Joe.
Yeah. You know, it's the oldest manuscript.
It's the oldest.
And it is super cool, man, because he's talking about Ice Age and dinosaurs and all kinds of cool stuff.
What are you
You.
talking about, man?
Hey, we got one last question before we. It's a good one. Well, you were one of my students.
By
I
the way,
assume
while
it would
she's
be.
taking her position, what did the XX chromosome say to the XY chromosome? I've told this joke before, but we'll see if you haven't.
And I did pay attention. It just
What's an XX chromosome come from? From a girl. What's an XY chromosome come from? A boy. What did the XX chromosome say to the XY chromosome? I like that, but it's, I like that. It's, do these genes make me look fat? Okay, go ahead.
Okay, so we saw the DNA and the cells dividing in that
Yes,
cell,
mitosis
whether it's
it's
a brain
called.
cell,
It could be any tissue cell,
any tissue cell.
any cell in your body.
Okay.
There's 1,000 different types of cells in your body that
Yeah.
do different functions.
Well, I got a couple missing because I'm old, but
We all do
now
it this way.
factor in and explain to me the fact that stem cells, because
Yeah.
there's cells that don't know what they are, and then
Yeah. Well, there's over 1,000 different cell types in your body, and some are more neutral to be utilized kind of multi-purpose. Kind of like, I'll use them this way. In baking, they're kind of like flour. I can do a lot of things with that, right? So there, in his design of cellular material in your body, there are some things that are just kind of brick and mortar things, and there were things that are, a lot of things could be made from them with different genetic instructions. And so there's really a masterful, beautiful plan behind the way he does this. But yes, you're just discussing, when we pick out one type of cell out of the thousands and say, well, what does this one do? Well, you have to look at it in the grand scheme of things. There are a lot of cells that are just nothing more than useful for building, enzymes. That's what they're really, they're like Legos for that. And that's their job, and they are put together this material is put together to make different types of cells to do different types of jobs. Skin cells, liver cells, whatever.
Let's give a round of applause to both Dan and Dave over here and Ward somewhere.
There he is. There's
Ward over
Wardy.
here.
Thank
Isn't
you
that
guys
great?
for your patience.
Hey, you all. I told you I used to work here for 5 or 6 years at the schools, and my hope is that you've sort of, through the 2 times we've been here with you, we hope that you've increased your faith. I'd love for you to go out and take over the whole community of Tonganoxie for Christ, because between you and we've been to the Baptist church down south, got a lot of people with a lot of faith. So go out there and get them and change this community, make it even better than it already is. So Jesus can do that for you. May the Lord bless you all, and we thank you that you've invited us to come into your lives.